Welcome to this overview of the Highway Capacity Software HCS 2010, focusing on the Streets module. I'm Bill Sampson, Director of the McTrans Center, responsible for HCS ongoing development and technical support. This overview is intended to illustrate some of the features of the HCS 2010 Streets module. A full tutorial is planned for inclusion of the software in addition to the current comprehensive and context-sensitive onboard help system. To keep this general, I will not be providing analysis details on the HCM 2010 process like phase duration, flow profile, delay computation, multiple peer analysis, queue storage ratio, and so on. McTrans presents 1-, 2-, and 3-day training courses to provide instruction on how to apply the HCM 2010 methodology properly in the HCS 2010. This is well beyond the scope of this short demonstration. Let's take a look at the main menu. HCS 2010 implements all analytical procedures in the HCM 2010 with intersection modules on the left, and highway modules on the right. We're going to focus on the streets module, where signals analysis is a one intersection subset of streets, and interchange analysis is usually a two intersection subset of streets. Multimodal analyses for pedestrians, bicycle, and transit riders level of service are included for both the signals and streets modules. Streets is accessed by clicking on it from the main menu. It brings up the streets module itself. Clicking on File New produces Quick Streets, which allows you to establish default values for all intersections and time periods for your data set. You can even save subsets of other streets files as templates to use to save time encoding similar intersections. I'm going to cancel this to instead choose File Open to generate a dialog for selecting existing streets files for this demonstration. You'll notice that you have the ability to open an old signals file with a .xhs extension or a data file from turning them account data collection as an XHD file extension. We're going to open a sample file from the Highway Capacity Manual, the first example file there. You first notice the toolbar. Lots of options. If you've used signalized intersections before in HCS, you'll note a few familiar things and some very different things. Let's just walk through some of the toolbar items so that you understand what is there and available to you with one click. You can hover over these items, these buttons, and you get a tooltip that says what each is. As you go through them, you can see them. Let's talk about them. We've seen File New and we've seen File Open. By the way, File Open does present you with a recent file list. If we were to do that again, you can see the recent file list. If you do File Open from here, you see the recent files that you can choose from. File Save just saves the file. You can do File Save As. You can print from the toolbar. This will print to the default printer. We'll go through most of these as we go through the demonstration. I'm just going to show you what they are now. Quick animation for generating and running a course simulation in animation form. Quick optimization for optimizing the signal timing using Transit 7F. Full optimization for optimizing signal timings, cycle splits, offsets, and so on using the HCM 2010 methodology under a genetic algorithm selection. You have a time-space diagram, flow profile diagram, auto-calculate, and force calculations. This becomes very useful if you get into big data sets where you have multiple intersections and multiple time periods where the amount of data is a little overwhelming for most computers. It would slow down data entry to allow the auto-calculate to continue. So you can turn auto-calculate off, continue with your data collection, data input, and knowing that the results are not being calculated until you tell them to with force calculations. The information button shown here in green. Green means that everything is normal. Yellow means there are warnings to present to you. Red means there's an error that probably is preventing results from being calculated. White means the data set is not yet complete. You have intersections in this data set. We have 2 intersections. You can add a new intersection. When you add a new intersection, you can copy. I guess we'll go through this in just a few minutes. Let's just do it now. You can do a copy. You can copy an existing intersection. You can create one from scratch, or you can pull an intersection from a signals file, a one signal subset of streets. Once you copy them, if you chose names for the intersection in this field right here, then those names would appear in this list. You can delete an intersection, but you can only delete the last intersection, so you have to work your way backwards if you want to eliminate intersections. You set a start time, and then if you add a time period, it'll add 15 minutes to the start time, assuming the phase duration, or not the phase duration, assuming the duration of the analysis is 0.25, representing 15 minutes in an hour. Notice that if you add a time period, here the demand with a single period analysis is expressed in vehicles per hour. But if you add a time period, it becomes a multiple period analysis. And this label becomes vehicles per period. And once you've gone into a multiple period analysis, you are coding the demand in 15-minute volumes directly. The peak hour factor goes away. But if you have a single period analysis, it's vehicles per hour, and the peak hour factor is in play. You can also see that we have one segment between the signals. Let's take a look at the help for a second. Help is here. If I bring up the help menu, I have several items I can pick from. To get help on the analysis, the first thing you would typically do is just click on Contents, and you can see that help is organized in this fashion, very similar to Windows compliant operations. The first thing you see is the license agreement for the software, acknowledgement for the software development, trademarks, things like that. HCM Chapter 17 for urban streets it's got a short description here, including the limitations of the methodology. The same thing for the signalized procedure in Chapter 17, limitations there. Getting started, lots of these things are probably self-explanatory. You can run a command line operation. Most people won't do that, but for running batch files, it is possible. You can mix and match root boxes of data to create data sets, which makes coding multiple intersections much easier. General controls, again, most of these are fairly obvious and consistent with the way Windows does things. You can look at multiple analyses in one screen and tile them vertically or horizontally. Reports, again, you can put the report to the right or to the bottom. We've added the ability to dock the reports to the right, especially to accommodate dual screen monitors or widescreen monitors, so you can see the analysis and the report at the same time more easily. These icons we're going over now. You have shortcut keys for most things. Some people like to do without the mouse as much as possible, and we've established shortcut keys for most of these toolbar operations. To get going in the operational data, you'll see that each of the areas of the screen that we're going to be going over there's a narrative providing information on how to code each of those things. And there's also F1 help. I call it F1 help, context sensitive help, that's available when you're on the screen, and in that field you get this same box that you do when you click on a highlighted or linked descriptor here. For traffic, you can see that it walks you through each one of these fields and a narrative that describes the input process, phasing demand, detailed data. We're going to go through each of these. I'm just showing you this available to you here in the help system. Back to the help menu. Beyond looking through the help itself, there is a user's guide. If you click on this, you essentially get a PDF version of the help that's built into the software. It might be helpful to print, have it available to you as you're working along, as opposed to going back and forth through the help, but that's there as well. HCS 2010 updates. If you click here, it'll go to the HCS page on the McTrans website and check your version compared with the latest version and prompt you if you need to update. Training courses. We offer, as I said, full training courses on the highway capacity manual procedures as implemented in the HCS with the HCS I pulled in. These can be 1 day on intersections, 2 day on everything, 3 day including hands-on operations. So this would take you to the training page to see what we have scheduled. The Highway Capacity and Quality of Service Committee has a web page. They're the keeper of the Highway Capacity Manual, and so that will take you there. Support. You can click here to go to frequently asked questions. There are quite a few, especially defining what's different about the HCS 2010 from previous versions. At the bottom of that screen, actually, we include something called known issues, where if there's an issue that has come up since our last patch, we typically will provide some sort of workaround to that issue, or we'll offer to send you an executable that's not yet been formally released to keep you going if that's necessary to overcome a particular issue. HCS 2010 tells you what's new about HCS and gives you some information about the ongoing development. McTrans on the web is just the McTrans website. You can read about different things go on, different products that we have, and order products there. Email McTrans is very helpful. If you email McTrans, it'll generate an email dialogue. It'll put your registration number within there. You can just type a question or anything you want to us. You can attach a data file, which I highly recommend. That usually helps very much. Most of these come to me, and we'll turn those around very quickly. The About screen does give you the version number that you're using. It gives you your registration number that your particular installation used. Both of those we'll want to know anytime we're doing technical support. Let's take a look at some of the fields. We'll come back to the toolbar buttons and the things that I've just glossed over in the help. In the general area, you'll see that this is just identify your analysis. Tabbing will take you to the next field in a logical order. This is a little different than the one before, however. Notice that if I'm in this field here, that the column and the row are highlighted in color, and you can navigate horizontally or vertically like you would in a spreadsheet. Whereas before you were stuck with the tab order that we had defined. So that's, we think, a fairly good improvement there. The first thing you're going to want to do typically is define the lanes. So if you bring up quick lanes, you can see that if you've used this before, it presents the same graphic interface that you've had in previous versions of HCS. You can add a lane by clicking on the button. You can take it away by clicking on the lane within the intersection itself, just to define the lane configuration as it is on the street graphically. For entering demand, typically you would enter the demand and hit the tab key. As you hit the tab key, it just takes you over one field at a time. So code a demand number, hit the tab key, demand tab, and walk your way through that. You can change all fields at once by holding down the control key and hitting the down arrow. You can, if all the lanes are 11.5 feet or something like that, you can, and the up arrow will bring it back, so that saves you a little bit of time there. Most of the rest of the fields on the left side of the screen are fairly familiar if you've used this before, and self-explanatory if you haven't. Again, a training course would explain how each of these fields is used in the computations, and so the more you know about that, the better your analysis is going to be. You can change things like how long a bus is typically stopped. You can change the passenger car equivalent for heavy vehicles. You can change how long a parking maneuver typically takes, all of which affect the adjusted saturation flow, and the more you do that, the better your analysis is going to be as a cumulative set of results. So each of these fields, again, is very simple. I'll point out a couple things here. Peak hour factor. You notice that the peak hour factor is 1 for the entire intersection. It's no longer available for entry by lane by movement. So it's 1 for the intersection. In fact, the Highway Capacity Manual now says that the peak hour factor should only be used in planning applications, that for an operations analysis you should be doing a multiple paired analysis coding 15-minute volumes directly, which eliminates the need for the peak hour factor. Over on the right side, things have changed. The procedure in the capacity manual now dictates use of NEMA phasing and many more controller settings, because it now produces a phase duration model. As you can see in the phasing view here, you can see that the phase durations are computed, they're estimated because the demand is known, the lanes are known, the available phases are known, actuation for each phase is known. So coming up with the average green time for the analysis period is something that a model can produce, and this one does. And you'll notice those values are different than the splits that are found below because of the demand levels over here. Let me show you how this works in the NEMA phasing situation. First, we have coordinated actuated here. That's determined because we've not checked the uncoordinated intersection box. I'll come back to that in just a second. Identifying the phases available, the NEMA phases available here, is just by toggling things on and off. For the left turn, you can take away the left turn phase, or you can add the left turn phase. If you have a protected right turn, or if you have an exclusive right turn lane, you can actually add a right turn overlap in conjunction with a left turn phase, and you just toggle through the stages with these buttons. For the through movements, you notice north and south has a left arrow and east and west does not. That means that this is protected only, and there are no permitted lefts allowed during the through phase. Whereas in the north and south, you have protected left turn phases and then permitted after the protected is over. That's reflected down here in the phasing view. You see the dashed left turn arrows here showing permitted lefts, and for east and west they're not there because there's no permitted lefts allowed. Below this you see, well, let's go back to uncoordinated intersections. The blue here shows that you've defined the phase 2 direction as eastbound, so we know that east and west is the coordinated direction on our arterial. So it shows that the east-west at phases 2 and 6 are actually the non-coordinated phases. When you have it set up as a coordinated operation, the cycle length is available to you, offset is available to you, and this is going to be honored during the phase duration process. When the actuated movement, the phase duration of the actuated movements are computed, if they are less than the maximum defined, then the extra time is going to go to the next phase, or to 2 and 6, depending on whether you define force mode as fixed or float. So in this case, you're seeing that it's coordinated actuated, and these things are available. And also notice that this first row down in the signal component area is phase split. Now let's see what happens when we make this an uncoordinated intersection. When we make it uncoordinated, the cycle length goes away. This becomes a maximum green instead of a phase split, and the phase duration is based on the fact that now 2 and 6 are also actuated. So it's a fully actuated operation now, and all the arrows are gray to represent actuated movements. Another thing that you can do is click on field measured phase times. If you do that, then whatever maximum green settings you have down here are going to be honored in phase duration. The phase duration model is going to be actually skipped. This is saying that you've measured the phase durations in the field, or probably more likely you've gone to your traffic management center and asked them to monitor the intersection while you were collecting data, and they came back and told you that the average phase times were these. If you know that, that's obviously better than the model, and you can code them directly and have them monitored. Side street split phasing is also supported in setting these modules up. You have minimum green, yellow, and all red times. You can set a left turn phase as lagging. You code the passage time. Recall modes can be off, min recall, max recall, ped recall. Dual entry simultaneous gap is there, as is Dallas phasing. So lots of options here. Some of it is quite new to folks that are used to using the old version of signals. Let's take a look at a couple of expanding on these things. What we did in this screen here is we we spent a lot of time trying to put together the subset of variables that most users would use, and so we've made this first screen as the only screen that many analyses will require. But there are lots more options and many more data fields that can be accessed should you need them. Let me click on detailed data and show you a few of these. Again, you see lots more things here. You have the ability, as I said before, to change the bus blockage time, to change the parking maneuver time, to maybe change left and right turn passenger or car equivalents because of the radius of the turn. You can get into critical gap settings here, sneakers, lots of information here, lots of access to the models if you have data to support changing them. Many users, however, will leave the default values here. Let's scroll down a little bit more. You see this set of data for access points. This is a major improvement to the model, modeling the effects of access points on travel speed and on platoon integrity between signals. So you can add access points, the lanes, and turning movement counts from those access points, locate the access point along the segment. So this segment happens to be 1,800 feet between signals. There are two access points at the 600 foot and 1,200 foot marks, and so you can define the data so that you can model the effects of access points on platoons and speed. We'll look at optimization in just a minute. You can see there are optimization settings here, and also those settings are repeated when you bring up the full optimization dashboard. This grayed out area is something that's coming very, very soon, is for interchanges. To do an interchange ramp terminal analysis, you have to define the interchange type. You have the ability to show turn radius. There's a segment length and interchange U-turn values that are coded as well. If I scroll down more, you see this section that defines the additional data required for multimodal input. So this gives you the ability to do a pedestrian and bicycle level of service analysis for a signalized intersection, and also a pedestrian, bicycle, and transit level of service analysis for urban streets. Much of the data that you put in for automobiles is used, but also you need additional data for the effects of these multimodal analyses. Notice this hide results button. We did that so that if you were not performing the other modes, that your results would not reflect just results from that get produced with essentially no data and only using the defaults. So we provided the ability to hide those results. Now you can collapse these screens back down. Let's take a look at the reports. If I look at the reports menu, I have several reports to choose from. The two at the top, the text reports for signals and streets, provide some intermediate results that are not shown in the formatted reports, or they're not formatted very well. If you need to dig into certain parameters, those are available to you here. But most of the time, you're going to be looking at what will default as a signals results report. The F11 key will turn the report on and off. That's useful for projection screens like this, where you don't have a widescreen monitor. If you had a widescreen monitor, you could have the report displayed as well as the full data entry screen, or if you had dual monitors, you can do the same thing. In this case, I want to be able to show you the full report, so I just toggle it on and off with the F11 key. In our report design, this upper level of the report in each of the signals report stays the same. It's meant to give you an overall snapshot of the signalized intersection, showing the lanes, the phasing, the phase duration results. You've got the movements and the demand for each of the movements. You've got cycle and split and offset information here. Then, for the results summary, we have these time results that come out of the procedure and the capacity manual, and then more familiar results here: adjusted saturation flow, capacity, volume to capacity ratio, queue storage, back of queue, maximum back of queue. This shows 50th percentile. You can choose to have that to be the 95th percentile or several other ones. You got uniform delay, incremental delay, full initial queue delay. They add up to be control delay for level of service for lane groups and for approaches and for the intersection as a whole. And down at the bottom, for signalized intersection, you have pedestrian and bicycle level service scores and level service values. This is the one-page result that most folks will use if that's what they want. You can choose the full report, which gives you the full 4-page report that includes the first page being input data. Again, the snapshot is at the top, and you see probably 90% of the input data shown in this one screen, including values for multimodal. You scroll down a little further, this is the results summary that went over just a few minutes ago. Then we present a third screen, again with the snapshot, that shows the intermediate results, adjustments to the saturation flow, effective green time, green to cycle ratio, and the factors that are put together for index scores for the multimodal portion of the analysis. The fourth page, this one is pretty much empty, but if we had warnings or errors, they would produce in the messages portion of this report, and the comments are from you. When an error or a warning exists, you can click on the information button, and it provides a place down here for you to type comments. There might be a warning up here that you fully expected, and you provide an explanation for. Or you might say, I overrode the bus stop 14.4 seconds because I know every bus has a bike rack on the front, and I overrode that with 30 seconds to have a better analysis. It gives you an opportunity to comment on your analysis that will show up in the results when you submit it to your client. Other reports, if you're doing multiple intersections along an urban street, then a segment report becomes important. This gives you base free flow speed and running time, ultimately travel speed, and percent base free flow speed. Travel speed as a percent of base free flow speed determines level of service. So you have percent base free flow speed, got level of service C, got an auto traveler perception score, and the other multimodal level service results down here. This section in here is showing you facilities. This is the segment report for one segment. In this particular analysis, we only have one segment, but you might have 10 segments. If you have 10 segments, the segment report is going to show you the results for the individual segment here. But down at the bottom, you're always going to see the results for the entire facility, which is essentially a linked weighted average of all the segment results. So if we had 10 segments, these would be the results for automobile and multimodal for one segment. These would be the results for automobile and multimodal for all segments combined for the facility as a whole. There's an access point report. If you've coded information about access points, the data are here, including proportion time block, which can be used in a two-way stop control analysis for adjusting conflicting flow for the effects of an upstream signal. That number comes from here. You're not going to use that probably. So most of these things are available to you. I'm trying to keep this from being too detailed. It's hard for me to stay away from talking like this as a training course sometimes. Let me get rid of the reports and show you some more of these toolbar items. Again, we have a very simple two signalized intersection analysis. It's example problem 1 out of the highway capacity manual. But let me show you, even with that, some of the things that are available to you. Click on a time-space diagram. Again, with two intersections, you're not going to see very much. You can show multiple cycles, reverse direction, or both. And you notice this is very, very poor coordination as the beginning of the green runs into the beginning of the red, because the offsets are just defaulted to 0. You can optimize. I'll show you how to optimize in just a few minutes. But another thing you can do is you can push these things around. You can push this up here, and either just graphically, you can improve immensely the coordination in both directions if you want to, right from here. So if you close this out, you're going to see the offset here is 0. If I go to intersection 2, the offset is 53, so it's giving you essentially a 50-second offset. I didn't push those around exactly right. Let's change them back to 0 so we can keep our data set intact for at least a few more moments. The time space diagram is quite a useful tool. Flow profile. Probably not most of us would use this too much, but it does give you an indication of the proportion of vehicles arriving on the green. And again, I switched this back to 0 offset, so this is not going to be as advantageous as you would like. We're going to see optimization in a minute. I'm going to show you what this screen looks like after we've optimized, and it'll show you the progression of the increase of the percentage increase in percent free flow speed as a graphic here. We talked about forcing calculations. Let's go back to, you can optimize with Transit 7F. If you click that, it's going to actually go off and get Transit 7F and pull your data set into Transit 7F and run the Transit 7F optimization tool and give you a results screen for both intersections here. So you can look at each intersection and the Transit 7F solution. You can also run full optimization using the highway capacity manual procedures. As I mentioned earlier, it pulls up a dashboard for you to change the kinds of things you might want to optimize. This is defaulting to percent base free flow speed, which determines level of service from the capacity manual perspective. But you might want to look at overall delay, arterial stops, arterial delay. You might have other objective functions that you want to optimize against. You can optimize cycle length. We've kept the cycle length at 100 seconds here so that the optimization process will go more quickly. But you might want to optimize cycle length, splits, offsets. You can even optimize phasing sequence, including or not including Dallas phasing. And you've got some settings here for forward direction, weighting, and some settings for the genetic algorithm process itself. Just to keep this simple, we're gonna run. Let's just make this 10 generations so that it doesn't take any time at all. If you were doing this for real, you'd want to let those generations go up to 100 or more. You want it to converge on the right answer. You don't want it to stop because it reaches the maximum number of generations. But in the interest of time, we're just going to run 10 generations. We'll keep the cycle length at 100 and just see what this looks like. It brings up a dynamic results screen, and you see that the original percent free flow speed was about 55%. And as it goes through the 10 generations, which ought to take about 15 or 20 seconds, it's going to improve that. Looks like over 20% right now. So instead of 55%, we're somewhere around 70%. So what that means is if you save this, go back to the segment report, you can see that the percent base free flow speed now is 65 and 75%. Level service C and B, and before both of these were somewhere around 55%. And if we had let it run longer, it would have gotten even better. The other thing that you can see here from the flow diagram is you can see the progression. Each iteration, each generation in the genetic algorithm process is improving things. So we were still on an upward trend. It probably would have gotten somewhat better had we let it continue further. The last button I want to show you is quick animation. If you click on this button, it converts the HCS file to a CoreSim file, runs CoreSim, and generates an animation file at the end without you having to know much about CoreSim. You can add vehicles, you can add traffic signals, you can zoom in, and typically you'll want to slow it down a little bit, and then you can play it, and you can see the vehicles progressing. These are your data, these are your signal timings, this is the distance between the intersections that you prescribed, and all of this is being animated from the data that you had. The next thing I want to show you is visual mode. Up until now, everything has been done in the classic scrollable screens. Even though lots of things are different, the look and feel of the interface of HCS is pretty much the same, but we have an option for you here. If you click on visual mode, you can see our two intersections are here and here, and as I hover over them, you get a quick snapshot of the delays for the approaches and the intersections. You can see that there are lots of things you can do here. This map, you can show, you notice there's a grid in the background. If I click on the grid, it comes and it goes. You can show the background image or get rid of it. You can set up different parameters for scaling and colors and lots of things here that gives you lots of options here. You can add intersections, you can add access points, you can curve this line. Let me show you that very quickly. If you needed for it to match the roadway, you happen to go this way, it would do that, and it would also rescale the distance here. Or you can bring it back to the way it was. You can see it down this way. Got lots of flexibility here. I'll leave it like that. Probably change it just a little bit. So you've got this map going on here, and you can pretty much pull in a bitmap image from Google Earth and scale it and put your intersections right here, so you don't have to worry about the distances, and you can have them oriented correctly along the map. An easy way to do it. Another option here is if I double click on an intersection, it brings up an optional way of coding your data. You remember in the classic mode you had the scrollable screens, you had where you can bounce from different screens, you could expand for detailed data and multimodal data. In this one, everything is contained in this screen, and you get the different sections of the data entry by tabbing. So you can go to the lanes, you can go to phasing, you can go to signal timing, the signal information, intersection information, general information. This is down in the detailed data now, so there's your pedestrian and bicycle interchanges, optimization, all these things you can do here. So it's a matter of preference. It's exactly the same sets of data, which is more comfortable to use. Scrolling or tabbing, it's an optional choice for you. If you double click on the segment, you get an intersection segment, you get the segment information as well. Back to classic mode to summarize. In summary, the demonstration was intended to provide you with some details on the operations capability of the Streets module within HCS 2010. I hope it served that purpose. It's not intended to be training. Training involves much information about the highway capacity manual procedures that we believe is imperative to do analyses correctly. So we do have training courses. You can check our site or give us a call. For any questions or technical support, you can contact me directly. My email address is bsampson@ufl.edu. The phone number is 1-800-226-1013. I'm at extension 1. I'm happy to help you in any way. General questions with HCS or detailed technical support, sending me data files. We do this all the time. We pride ourselves on turning these things around quickly. So please contact me if there's any way you think I can help any way in the future. And thank you for listening to this demonstration.